Okay, so what we're going to start out with for this class is reviewing dimensional analysis. All right, because dimensional analysis is going to be really important. We do stoichiometry basically the entire year this year, and so we're going to start out with dimensional analysis. Of course, the first thing we're going to look at is cross-canceling. So for this, right, cross-canceling, you've got 3/2 and 1/3. So really all that you're going to do is cancel out your 3's, all right, leaving you with 1/2. And then, of course, the same thing can be applied if you have no numbers. So x over 1, y over x, right? You can do the same thing. Cancel out your x's, leaving you with y over 1, or of course, y, because anything over 1 is itself. So part of dimensional analysis definitely has to do with measurements in units. And so just to remind you of the units that we use for measuring, of course, we measure length, we measure volume, and we measure mass. And for each of these things, there is a standard unit in science that goes along with it. For length, that's meters, volume is liters, mass is grams, time, seconds, temperature, Celsius or Kelvin. Definitely not Fahrenheit, though. And then the metric prefixes. So I know that you are all at least somewhat familiar with metric prefixes at this point. You will want to have a pretty good grasp of them in your memory for this class, because I'm not sure that you will be told any of these metric prefixes when it comes to the test. So learn your metric prefixes. Okay, so conversion. Hopefully everyone remembers how to do this. I'll just start by going through units. So if we're starting in meters, of course we want meters to cancel out. So the meters have to appear on the top and then the bottom so that they cancel out. And then we convert from meters to decameters, so then we can convert from decameters to hectometers, right? Decameters, top and bottom, they cancel out. Hectometers to kilometers, right? Hectometers cancel out. And so at that point, we are just left with kilometers. Now, of course, if you know how many meters there are in a kilometer, you can just do one step and convert directly from meters to kilometers. Now, if we add in numbers, right, it'll look a little more like this, with all our units canceling out. And we remember that anytime there's a number that is not 1 on the top, we would multiply. And anytime there's a number that's not 1 on the bottom, we divide. So this would be 10 divided by 10 divided by 10 divided by 10, right? And so that's going to give us an answer of 0.01 kilometers after our math and canceling out is done. And if you remember that there's 1,000 meters in a kilometer, you can condense it down into one step. So the main takeaways from this first part: units are important and they should be with every number. Units can be cross-canceled just like variables or numbers in math. And metric units are associated with powers of 10, right? That's why they are so much better than English standard units. So moving on into the second part of the little dimensional analysis review here, right? It's going to be that chemistry has units as well, right? There are specific chemistry units. We will see many of them, but the first 3 that I'm going to remind you of: Avogadro's number, right, with units of atoms per mole; atomic or molecular mass, that has units of grams per mole; and then, of course, density, that has grams per milliliter or cubic centimeter. So, difference between molecular and atomic mass. Hopefully you remember this, that elements have atomic mass and molecules or compounds have molecular mass. So to find the molecular mass of a chemical compound, you will add the atomic masses of all the elements in that compound. So if we start with carbon dioxide, right? We know that we have carbon, we know that we have oxygen, and we know that we have 2 oxygens. So we look on our periodic table and we find that carbon is 12.011, and we add to that 2 oxygens at 15.999, and we get an answer of 44.009 grams per mole, because that's what the units of molecular and atomic mass are. Okay. So then, if we have something like sodium acetate, right, we look, and again, we have sodium, we have carbon, we have hydrogen, we have oxygen. We know that we have 2 carbons, 3 hydrogens, and 2 oxygens. And so we're going to set it up basically just like the last one. We find the atomic masses for all of these, right? Sodium, 22.99, 2 carbons, 3 hydrogens, 2 oxygens, and we do all that math and we end up with our molecular mass. And it's as simple as that, right? Some elements or some compounds certainly have more elements in them, but that's all there is to it. Okay, so then if we start looking at some dimensional analysis, right, we might be asked questions like 10 grams of copper is equal to how many moles? And so we're going to start with what we know, right, which is that we have 10 grams of copper. And if we want, right, we can put that over 1. That's perfectly fine. And then we're going to find the atomic mass of copper, which usually is presented as grams over moles. However, that's not useful. So I'm sure you all know we just flip it so that the grams cancel out, right? We're going to do 10 divided by 63.546 to get an answer of 0.157 moles. Hopefully you are all remembering how this works and that this is not anything new to you. So then if we had something like 2 moles of zirconium has a volume of how many liters, right? We will not be able to convert directly from moles to liters, but we can get there, right? Again, we'll start with what we know. We know we have 2 moles of zirconium. We can put that over 1. Then we find our atomic mass, right? Because that has units of moles that we can cancel out. Then we're going to convert grams to milliliters. And then, of course, the final conversion, a metric conversion, milliliters to liters. Everything cancels out. So we have 2 times 91.224 divided by 6.506 divided by 1,000 to give us our answer of 0.0280 liters. Okay, so main takeaways from the second section. Units like our atomic mass here, grams per mole, can be flipped, 1 mole per number of grams, for cross-canceling as long as the numbers stay with the correct units. When calculating, if the number other than 1 is on top, you multiply. If it is on the bottom, you divide. And when trying to cancel units, the unit on top in our current step has to appear on the bottom of our next step, well, or some other step in there for us to be able to cross cancel it. Okay, that's it for a review on dimensional analysis. I will see you in another video.